First one, a rocket is stationary on the ground on the launch pad at time t is equals to 0. This is the acceleration time graph. The rocket engine the rocket engine are switched on and exhaust gases are ejected from the nozzle of the engine. The rocket accelerates upward, so you can clearly see that the acceleration is increased, and at this point, acceleration is constant. Figure 1.1 shows how the acceleration of a rocket varies between time t is equals to 0 till time tf. Define acceleration. So definition of acceleration, it is a rate of change of velocity or change in velocity in unit time. You can write the formula, but better write in words that the change in velocity per unit time. Formula is also acceptable, like v minus u over t. The next part on the figure 1.1, sketch a graph, show how the speed of the rocket vary from time between t is equals to 0 to tf. First thing, for a speed time graph, what slope represent? Slope represent acceleration. Now, first what is happening? The acceleration is increasing. As you can see the acceleration time graph. So if acceleration is increasing, what happened to the slope of this line? So we should draw a graph for which first the slope will increase. So in the way, and how we draw a line for which the slope is increasing? So this is a line for which the slope is increasing. Then here the acceleration is constant. So constant acceleration means slope should be constant. And how we represent a constant acceleration or constant slope? So first part, because acceleration is increasing, so the slope should increase. The second part, acceleration is constant, as you can see from this graph. This part acceleration was increasing, and the other part acceleration is constant. And for speed time graph, the slope represent acceleration. So first part of the graph, the slope acceleration is increasing, so slope should increase. And the second part of the graph, acceleration is constant, so slope is constant. So we will draw a straight line with a constant slope, which shows at this part the slope is increasing, which shows acceleration is increasing. The later part, the slope is constant, it's a straight line. So if the slope is constant, it means the acceleration is constant. Is it clear, this part? It should be a curve and a line. The reason for that, because acceleration is not constant, acceleration is increasing. So how we show our increasing acceleration? It is by a curve for a speed time graph. So it
So
should
can
be,
we make a curve
yes.
and then a line going upwards, like, or does it have to be right?
Can you repeat what you mentioned, Hamza?
Like a graph, a bending graph, and then it goes upwards straight.
Means you want to draw like the first part is like this. You mean this one?
No, not like this. Wait,
Then
screen out
you can use the
like,
screen annotation. What type of graph you want?
like this.
Yes, you can draw like, but you have to keep in mind, as you can see, the time axis, like just judge according, there is no scale on this, but you can judge for greater part it was accelerating, and then for short period it was constant acceleration. So greater part we should have acceleration, and then constant acceleration. Like acceleration changes, and then there's a constant acceleration.
Thanks.
In part C, sometime later, the rocket is far from the Earth. The effect of the Earth's gravity on the motion of the rocket is insignificant, means the gravity is not acting or affecting its motion. As the rocket accelerates, its momentum increases. State the principle of conservation of momentum. What is the conservation of momentum? It states that in an isolated system, like the system which is not affected by external condition, the total momentum before collision is equals to total momentum after the collision. That is a principle of conservation of momentum. Explain how the principle of conservation of momentum applies to accelerating rocket and the exhaust gases. Means the rocket is accelerating, how we can apply this principle. So what happened? Because what happened for rocket as it is accelerating, the total momentum is conserved. Like example, if the total momentum is zero, say a rocket is there at the launch pad, so starting momentum is zero. If starting momentum is zero, the final momentum should also be zero. But how the final momentum is zero? As this rocket burned the fuel, so these exhaust gases will move. If the exhaust gases are moving downward, the rocket will move upward. And the momentum, the downward momentum and the upward momentum should be same, because if the total or the initial momentum is zero, the final momentum should also be zero. So when this rocket is ejecting the gases, the momentum of the gases is same as the momentum of the rocket. So rocket gain momentum by ejecting the gases equal momentum but in opposite direction. That is right. That is the principle of conservation of the momentum. Uh, so rocket propulsion based on this conservation of momentum, ejecting the gases equal to the gas gain moment. The rocket is gaining momentum, exhaust gases equal to the momentum, but they are equal in magnitude but opposite in direction. Question 2, figure 2.1 shows a sign that extend over a road. Accident, slow down. Calculate the mass of sign, which is the mass of the sign is 3.4. Calculate the weight. So how to calculate the weight? Weight is mass multiplied by gravity. W is equals to mg. So 3.4 into 10 to the power 3 multiplied by gravity, which is 10. So it will become 3.4. As we know, the weight is equals to mass times the gravity. So that will become 3.4 is the mass and the gravity is 10. So when we multiply these two factors, we will get 3.4 into 10 to the power 4, and the SI unit of the weight, that is Newton. The next part, the weight of the sign act at a horizontal distance of 1.8 from the center of the support post, and it produces a turning effect about P. So when they say about P, means we have to take P as a pivot. About this point, so P is our pivot, point of rotation. Point P is horizontal distance 1.3 from center of the support. Calculate the moment about P due to the weight sign. So how we'll calculate the moment? So this is the P, the axis of the rotation, the point of the rotation. Weight is acting downward, so as the weight is acting downward, which direction it will cause a moment? It will cause a moment in clockwise direction. And how we will work out the product? The moment is the product of force and distance. So force, that is the weight, and multiply by distance. What is the distance here? We always take a perpendicular distance from the pivot. So if I extend this line, the weight, so what is the perpendicular distance? This part is a perpendicular distance. So that is 1.8 minus 1.3, which is equals to 0.5. And weight we already calculated, which is 3.4 into 10 to the power 4. So weight multiplied by distance, or force multiplied by distance, we'll get this clockwise moment. Is it clear? So 3.4 multiplied by 0.5. Into 10 to the power 4 multiplied by 0.5. So that will guess the Newton meter. Why we cannot take 1.3? Because we always take a distance from the pivot. As they already mentioned in the question, you have to take about P. So P is the pivot. So we have to take all the distances from P when we are calculating a moment. And all the distance, the force and distance should be perpendicular. We always take a perpendicular distance between the force and the distance. So weight is acting downward. If I extend this line, so this is 3.4 into 10 to the power 4 newtons. And what is the distance from the pivot? The perpendicular distance. So this region, this is a perpendicular distance. That's why we are taking as 0.5, not 1.3. The next part, the concrete block is positioned on the other side of a support post with the center on the mass horizontal distance 70 centimeter from center support. What is meant by the center of the mass? The definition of the center of the mass. The center of the mass means the point where whole weight of an object acts, that is known as the center of mass. In A levels, you will study about the difference between center of the mass and center of gravity. There's a difference between them, but right now, as in O levels, you're taking both as same. So point about where the entire weight of a body seems to act, or point where the mass of an object is concentrated. Both definitions are correct, but this definition in A levels you will learn this is about center of the gravity, and this one is about center of mass. But you can write both of them right in O levels. Both are the correct definitions. Then the weight of a concrete block produce a moment about P that exactly cancel the moment of the weight. Calculate the weight of the concrete block. So basically the clockwise moment and anti-clockwise moments are same. If this is our pivot, the point of the rotation, the weight, this weight is causing a clockwise moment, and the concrete block is also having a weight, the force is there. and that will try to cause an anti-clockwise moment. We always take the distance from the pivot. So the first distance, the clockwise moment equal to anti-clockwise moment. So the distance of the weight, we already know that is 0.5. This was 0.5. And what about distance of the concrete block to the pivot? That is 1.3, and this is 70 centimeter. So 70 centimeter should be 0.7 meter. So 0.7, and this is already 1.3. So that will make it 2. So clockwise moment and anti-clockwise moments are same. So I can say F into 2 is equals to weight multiplied by the distance from the pivot, which is 0.5. The force we don't know. The distance is 2. The weight we know, that is 3.4 into 10 to the power 4 times 0.5. This is multiplied. 2 will be divided there. So that will be 3.4 into 10 to the power 4 multiplied by 0.5 divided by 2. What is the answer for this part? The weight of the concrete block. $8,500. So this weight will be 8,500 newtons. The next part, the concrete block is removed. The sign and the support post rotated about P in a clockwise direction. State and explain what happened to the moment about P due to the weight of sign as it rotates. Look, what they mention here that we remove this block which was placed initially as a support, that is removed. As this block is removed, you can clearly see the weight will cause a clockwise moment. As the weight will cause a clockwise moment, then the question is what happened to clockwise moment as it is rotating. So the clockwise moment continue to increase. Why the clockwise moment continue to increase? As this object will topple, because this is the original position, but as the object topple, the position of the weight will shift slightly towards right hand side. So moment about P increases, moment of weight about P increases because the distance of the weight from P increase. That's why the moment increase, or it will topple. Already they mentioned we remove the block, so it is toppling. So the answer here, moment about P due to weight increase, and reason for that because there is an increasing distance between the weight and the pivot, the point of rotation, which is P. So when the object is toppling, like example, say you have an object which is slightly tilted, and the weight of the object is acting down. Now what happened as this object, as it topple, the new position of this object is this. So you can clearly see when I show an arrow to represent the weight. So you can clearly see the weight, the distance between the pivot and the weight increases. So that's why the moment continue to increase. In the beginning, both cases, the resultant moment is a clockwise direction, but that is continue to increase as the distance from the point of the rotation or the pivot is increasing. Same thing happened for this sign as well. As it topple, the distance between the weight and the pivot increases, or the point of rotation P increases. That's why the clockwise movement will increase. A cube of side 0.04 is floating in a container of a liquid. Figure 3.1 shows that the surface of a liquid is 0.02 meter above the level of bottom face of the cube. The pressure of air above the cube exerts a force on the top face, and the valve is closed. This valve is closed and there is a pressure of the air at the top. Explain in terms of air molecule how the force due to the pressure of air is produced. So these air molecules are moving randomly. Air molecules are continuously changing their direction and they collide with the surface. So air molecules moving randomly continuously collide with the surface. They change the momentum as they bounce back. Exert force which create the pressure. Because whenever there is a change in momentum, there is always a resultant force, and resultant force is responsible for creating a pressure as it is acting on a unit area. The density of the liquid in a container is 1500. The pressure due to the liquid at a depth of 0.02. So what is the pressure due to the liquid? As we know, the pressure exerted by the liquid depends on the density, gravity and depth. So rho GH or dGH. Always write the formula when you are solving a question. So density is 1500, gravity is 10 and the depth is 0.02. What is the final answer? 420 Pascal. That is the pressure exerted by the liquid. The force on the bottom face of a cube caused by the pressure due to liquid. So we know the pressure due to liquid, and how to calculate that force. Pressure is force over area. So force is pressure multiplied by area. The pressure to get the area, so what will be the area for this? As I already mentioned, when you check the figure for area, a cube of side 0.04. So the side, this is a cube, so area of the cube, it will be length into width. So length, all the sides are same, so length is there and the width is 0.04. That's why we multiply them. 1.6 exponent minus 3 will be the area, and that is multiplied by pressure, which is 420. We will get the final answer. So 0.67 Newton is the force. The next part, the valve is opened. So they open the valve and the liquid is pumped into a container. So they push the liquid into a container. The surface of the liquid rises to a distance of 0.0 0.034 meters. The cube remains floating in the liquid with the bottom facing phase 0.028 below the surface of a liquid. Calculate the work done. So work done is force multiplied by distance. The force which we applied, that was 0.67, that is the same, and how much distance it moved, it rises to a height of 0.034. So work done, which is force multiplied by distance, 0.067 multiplied by the distance, which is 0.034, you will get 0.023 joules, because it is energy or work done. Suggest one reason why this is not efficient method of lifting up the cube. Why this method might not be efficient to lift the cube. If you want to lift the cube, this method, because what happened in this case, what we are doing, if we want to lift a cube, but to lift a cube, we have to lift the liquid as well. So when we are doing a work done, we are pumping the water. So we have to pump in or provide a sufficient energy so that we can lift the water as well, or we can lift the cube. Like, it's not like directly lifting the cube. We have to lift two things. We have to lift the cube as well, and we have to lift the water. That's why it is not efficient, because our energy should be used only to lift the cube, not to lift the water. But in this process, we have to lift the water as well, or the liquid which is used here. So why this method will not be efficient? Because the energy will be used to lift both cube and the liquid, or some energy might be lost due to friction between liquid and the pipe. So these are two reasons why this method will not be efficient. Because efficient method means that it will convert most of the energy in the useful one. But in this case, the energy which you use, some of the energy is used to lift the block, the cube, and the some of the energy is used to lift the liquid. In this question, a gas of mass 0.23 kilogram is trapped in a cylinder by piston. The gas is at atmospheric pressure, which is 1 exponent 5 Pascal. Figure 4.1 shows the piston is held in a position. So a piston is, this is a catch which is stopping a piston. A volume of the gas trapped is 1.9 exponent minus 4, that's the initial volume. Electrical heater is used to increase the temperature of a trapped gas by 550 degrees centigrade. Specific heat capacity is 0.72. Calculate energy required to increase temperature of a gas by 5. Specific heat capacity means how much energy required to increase the temperature of given mass by 1 degree centigrade. It's a specific heat, so Q is equals to E is equals to Cm delta T, or C is equals to E divided by M delta T. C is a specific heat that is given. M is a mass that is also given. The temperature increase, that's the temperature change. So we need the energy. So if we need energy, E is equals to, when we rearrange the formula, E is equals to Cm delta T. So it will be 91.1, and the unit of energy is joules. The formula for specific heat is equal to energy divided by mass into temperature change. This is the formula for specific heat capacity. You need energy, so energy is equals to specific heat multiplied by mass into change in temperature. The specific heat capacity is given here, which is 0.72. So 0.72. The mass of the gas is given 0.23, and the temperature change, as I mentioned, increase the temperature by 550. So temperature change is 550. When you multiply all these factors, you will get 91.08, which is 91.1 joules. The energy which is used to increase the temperature of a gas of mass 0.23 gram trapped in this cylinder. The power of the heater is 2.4 watts. Calculate how long it will take a heater to supply the energy we calculated. So how we'll get this energy? We know energy is power multiplied by, because power is energy divided by time, and we need a time here, so time is energy divided by power. Energy is 91.1 and the power is 2.4. So 91.08 or 91.1 divided by 2.4 watts, that is equals to 37.95 seconds, which is approximately equal to 38 seconds. In practice, it takes much longer to increase the temperature of a gas by 550. You suggest one reason for that, like we want to increase the temperature of a gas which is trapped in this cylinder to 550, but practically we calculated like it should take approximately 38 seconds to reach the temperature of 550, but in practical it need different temperature, like it need more time. So what could be the reasons? The reasons are because first thing, the heater will take some time to heat up. The second thing, heat might loss to the surrounding. So heater taking time and heat loss to the surrounding. These are the things which result, and energy also used to increase the temperature of the cylinder and the piston as well. Like some of the energy will be absorbed by the piston, some of the energy absorbed by the valves or the of the cylinder, some energy might be lost, or heater might take some time to heat up. That's why practically you need a longer time as compared to what we calculated in the previous part. When the temperature of the gas has increased by 550, its pressure is 2.9 exponent 5 Pascal. The catch is then released. As the piston moves, the temperature remains constant. State what happened. State and explain what happened to the piston. So as the piston is released, what happened to the piston? The catch is basically, yeah, at the piston, because originally the initially when you check, the pressure was only 1 exponent 5 Pascal. The outside pressure is 1 exponent 5 Pascal. That's the atmospheric pressure. So inside pressure was also same, and the catch was keeping it at same position. Now when we remove this catch, and the inside pressure is about 2.9 exponent 5 Pascal. So what happened? The pressure of the gas is higher. So the piston will move towards right hand side. Or it will move outward. As the resultant force is towards the right hand side. The next part, determine the volume of the gas when the piston is moving. So for this one, we know P1 V1 equal P2 V2, because whenever there is a gas and the temperature remains same, so the formula which relate the pressure and volume, that is P1 V1 equal P2 V2, as they are inversely proportional.